All right, so the warm-up. And things that you will need to be able to do on the quiz on Monday. This time, I'm asking you to write them yourself. So state the limits at the left and the right side of x equals 3. So Dylan, what's the first thing we need to do?
Wouldn't you want to use like 3, see what it is at 3, because...
Okay, that's this question. What is the value at 3? That's not part A. It is a thing we need to answer as well, but... Kevin, what were you going to suggest?
Write down limit f of x and then do the x point 3 and a negative 8. Yeah, and then do the other one without the negative. And make
We got to say to the plus.
Yeah.
Okay, so hang on, right there, perfect. This is what I, like, when you see it saying, tell me these limits from the left and the right, Kevin's got it exactly. From the left and the right of 3, so LIM over that x arrow 3 to the minus and x arrow 3 to the plus, f of x equals. And Bailey, you were saying, reading this, is that the to the left, the side with the smaller numbers, or to the right, side with the bigger numbers?
To the left.
To the left. So we're going to plug in 3 to this stuff here. So Boaz, 2 times 3? 6. Yep. Joaquin, the other side from the right?
15 minus 9.
15 minus 9.
6.
Gideon, what is f of 3?
6.
The equal sign is on this one, so it is also 6. All right? So, Tessa, is f of x continuous at 3?
I said yes.
Okay? I agree. And the question is why? And writing it as limits. The reason is the road from the left and the road from the right of 3 is going where the bridge is. Like all the things are glued together, it goes nicely and you can continue. Emmy, can you put the laptop away? And Beckham and Jasper, thank you. Checking who's absent. Go ahead, your phone, please. Yes.
Can you explain the use limit to justify your answer thing?
So continuous, kindergartner test of continuous is you can put your pencil down and draw the whole thing. So it's continuous if sneaking up on it on the left side and sneaking up on the right side is exactly where that crayon was supposed to be. So that's what these limits are saying. The limit from this side and that side, on the left and the right, they equal each other. This limit equals that limit, and it's where you wanted it colored in. If it was a removable discontinuity, the limit would equal the limit from the right, but that last thing would be different. That's works?
Yeah.
Cameron, number 2 here. What's the start? What did Kevin say our start was when it says state the limits?
LIM over x to 1 negative, or like the thing, and then g of x.
And then the other piece, like just setting it up. So that's from the left.
Oh, all I'm doing is setting it up, and then the plus.
Okay, yes. So Natalie, looking at these things, which one is to the left, the one on the top or the one on the bottom?
One at the top is black.
Yep. Nate, why is this one left?
Because if one is greater than x, then x has to be somewhere between negative infinity and
Well,
what as close as you can.
numbers smaller than 1 are on the left side of the graph.
Yeah.
It's all good. So Ally, plugging into this top piece to get the stuff on the left, what's the y value gonna be? 2. Ashley, plugging into the bottom to get the side from the right, what do I get? Yep. 4 times 1 minus 3, we get 1. Jonathan, what is g of 1?
As said, undefined.
It's undefined. Jasper, do you agree? Yeah. In the description of the function, I don't say when x equals 1, do this. I just don't say anything. So does not exist or undefined, I will take either one. So Spencer, is it continuous?
No,
No. Why not?
because it doesn't ever like the multi-equal sign underneath.
Okay, because at 1 it's not defined. What kind of discontinuity? Sophia?
I'm not sure.
Well, let's think about it. 1 from the left is going to 2.
Jump.
There you go. So you don't have to graph these, but looking at your answers to those limits, I went here and I went there, 2 really different places. This is a jump discontinuity, and why? Here is your justification. The height from one side is not the height from the other side. There is no little bridge that you could build to go over that gap. Make sense? Okay. Can we look at the worksheet from yesterday? And 2 days ago? The kinds of things that I saw in 7th period. People drew both lines without stopping. The issue here, sorry Tessa, just a second. Like, you only draw this line for these x values, and you gotta stop. And the other line you only draw for the other given values. Tessa, what was your question?
For the range, I had is -6 and not -7.
Let's see. When we plug in -1 to here, which you're right, it doesn't say equals, but 3 times -1 minus 4 is -7. So if I could get to -1, that height would be -7. But -6.9999999 is technically less than -0.99999 is technically less than, greater than -1, so I would plug that in. So where it breaks, if you can put the number in, do that and see what number comes out and you put a round circle on it. Chloe, does that make sense? Okay. Other questions with how this looks or what the answers are? Bailey?
I think I'm just like graphing it wrong.
Okay.
My line, so like the line for the first equation is right, but for the second one it's like way more.
Okay. So let's graph the second one again with geometry instead. Looking at the equation of the line, can you tell me, oh, is mine way off? So is it the right-hand side that's graphed wrong on your paper?
Yeah.
Okay, so looking, that's the top thing. Looking at the
No,
equation.
it's the one with the fraction on
Okay, all right. Then looking at this one. What's the y-intercept of that one going to be? Looking at the equation. When x is 0, where would it hit the y-axis? That would be the b value of this.
I did 2.5.
Okay. Yes, you're right. So when x is -1 times -1/2 plus 2, 1/2 plus 2. So at -1, we went up 1, 2, and 1/2, and I closed in the dot because it has an equal sign, right? Okay, now it is fractions and they're harder. Plugging in, I'm gonna pick a number bigger than -2, like, I'm gonna pick a different even number, maybe like -4. (1/2) times -4 plus 2, half of -4. So at -4, 1, 2, 3, 4, we're gonna go up 1, 2, 3, 4. So getting 2 points for that straight line, and then you can just draw it, is all you need to do.
Okay, so like when we're doing like the T-chart, how many x values we want to do like?
Well, okay, when you're doing the x values for the t-chart, a lot of you will do -1, -2, -3, and that wasn't very much distance between them. So it's a good idea to get 3 or more. And I like to get one that's further away so that I get my straight line clear. Oh, and the kind of discontinuity, I think it was Spencer was like, oh, that kind is a jump, because the y value here, the y value there, you need an elevator to get your car from one side to the other. Yeah? This one. Can you guys look at your graphs, and if you don't have this part drawn, can you put it in? A lot of you stopped at x equals 6, but there's a whole bunch of numbers. I think it was someone from the back tables yesterday said, well, how can you tell when they're going to do that swoop? Is it when there's an x thing in the denominator? Absolutely, yes. So this thing in the denominator, when is that 0? At 5? That x equals 5, you guys know that's a equation of a vertical line. Hang on, Tessa, just a sec. So there's going to be a vertical asymptote right there. Yes, ma'am. What's your question?
So anytime there's an x in the denominator, it's gonna do that thing with the asymptote.
Okay, so what we're getting to next is a thing called rational functions. And there's going to be a whole lot of mess. So we haven't done this yet, but that's going to be a removable, it's going to be a blip on the like that would be a hole. There would be a little hole, and the thing that's still left down there, that's going to cause that vertical line thing. So you did asymptotes in Algebra 2? Just horizontal, or did you do vertical ones also? Vertical. Leah's saying she did vertical. Spencer, any? Both of them? Okay, so this shouldn't be completely brand new. Are you guys okay with the answers? Ooh, and the range. Where does the y value start? I don't have anything, don't have anything. Then I have y equals 4. A whole lot of y equals 4. -4, I should say. So it looks weird. Can you guys write down that if you don't have it written this way? So the range is -4, that one number, and then everything bigger than 0. And a round bracket on 0. Tim, why is it round?
Because 1 over x minus 5 never hits 0.
Because 1 over x minus 5 never gets 0. It gets super, super, super close, but never hits it. So it's not sorry, Holiday.
No, never mind, sorry.
Never mind,
I'm
sorry.
getting mixed up.
Okay, Tessa?
For approaching 5 from the positive numbers, how did you get infinity?
Okay, 5 from the positive side, so like 5 and 1/10, 5 and 100, 5 and 1,000th. If I plug that in to here, 5 and 1/10 minus 5 is 1/10. What is 1 divided by 1/10? Dividing by a fraction is multiplying by the thing flipped. So this becomes 10. So 5 and 1/10 is up here. 5 minus 5 and 100th minus that, that's gonna end divided, sorry. As we get closer and closer to 5, it's 1 divided by a smaller and smaller fraction, which means it's really that big number. And feel free to check Desmos with the graphing to see that you're getting them right. So Jean Gideon, what kind of discontinuity is this?
Infinite.
Infinite. Even though, Naomi, even though this side went to 4 and that side went to infinity, it's still infinite? Because infinity is a lot stronger than -4. Yes? Here? Yes? All right. Number 3. Some of you graphed 2 things. You graphed a line of y equals 1. I didn't want the line. I want only this coordinate. When x is 2, it's that 1 dot. And if you can't see it back there, this has, whoa, this has a big old circle for the open hole. So Emmy, what kind of discontinuity would we call that one? Don't know? Charles, what kind of discontinuity? What is it? Jump? Could we glue in one little place, like if I put a drawbridge down, would we be able to drive across the road? Ellie, what do you think? What kind of discontinuity is it? Removable, because that's what it says on the board, yeah? Guys, things that are just a little cut, a little tiny single circle, and the road from one side is going to the same place as the road from the other side, but the bridge is washed downstream. That's removable. If you glued it in the right spot, not continuous. Sorry about that.
Sorry.
Handwriting. Not my strong point.
It's all good.
Yes, Kevin?
Is for domain, is that a 0 or is that a negative?
Okay.
For x value?
All of the numbers that were ever numbers, it's negative infinity to positive infinity. And those of you that are doing these in pen, I highly recommend you either get erasable pens or embrace the pencil that can erase. Because some of you have graphs that are drawn on top of each other, and then you have other things, and then you scratch things out, and you can't see what's going on. So I'm a bit concerned. So let's see, we had a thing that was continuous, we had an infinite, we had a removable, so the next one is probably the other one that's missing. Sorry, we didn't have continuous. That's this one. We had a straight line and a parabola, and they glued in at the same spot. This one's continuous. Joaquin, yeah? You have that one drawn? Oh, you don't have anything written on there. Huh. So let's see. Again, today's Thursday. We have the rest of today and tomorrow to get you guys ready for a quiz. Are you able to graph? Some of you are like, no, not at all. Because for the weekend, not tonight, but for the weekend, I want to give you guys a Delta Math to have it check you. Graphing in Delta Math is hard. So I want to show you how that works. Trying to bring it up, just a second. Okay. These are all not what I wanted to show you. All right, not sure this is the best thing. Yeah, never mind. Don't want to do this. Okay, can you guys work on the packet, page 7? Be careful with number 4. I'll come around and help and check.
So for 4, it's 1 over x minus 2. So would you just do, so would it just be 1/2?
I mean, 4th grade, so then once you plug in,
You plug in 4 for.
yeah, it'd be 1. But then what about, yeah. If you plug in 4 on the bottom as well as 4 over 8. Alright. Let's take the left and right hand limits of x. Which would be,
So if you
LIN.
h of x, 4 to the left and then 4 to the right, and they're both 1/2.
Did you get for the x values? Or just 1/2 for both?
Yeah.
Alright, but is this a, is this continuous next to this
It's gonna be
floor?
at 4
Right, this will always be six.
That question does count.
It'd be easier to understand, like if we could graph it, it'd be easier.
Yeah. Continuous would be like, you don't have to like, continuous is like you can continue it without lifting up your pencil, right?
Yeah.
So wouldn't it not be continuous because you have to do one half and then on the left and the right?
Yeah.
Yeah, I don't know.
One of the,
Bro, but have you seen the clip, are you gonna talk about his dying here? Have you seen the clip where he's like,
What do you guys think for the?
he's like, it's worth it that like a few Americans die from gun death? Yeah, it's like it makes it worth it. It's like it makes it worth it to have like our
I
rights
said,
intact and you got.
0.5,
I feel bad for like his family. Nobody. I swear, no, it hit like, bro, 'cause I feel like you have to, and I'm just gonna like go home and like leave
If you're
it.
securing
like the bell,
at that point, no.
and then
It's
there's like a bunch
protect them.
of, it looks like a, you know,
This is being recorded and this is
Well,
our conversation, so
everyone
everyone
can
can
have
help
on
on
time.
time.
It's a really bad idea, I really.
Just a heads up.
Which,
Sorry, Sophia, just a second.
I don't know, I kind of pick them up, I guess, you just learn the thing right, and then you get like a feel for it, you understand it. And they find it. Anyways, it's really difficult, so not a lot of people know.
I've watched the videos and you can't hear it.
Bro.
Alright, if it's recording, you know that in that moment.
If you're the security guard, you gotta get this off. What do you mean, what's the point, dude? I'm just gonna like, oh shit, got shot,
Oh,
let's
yeah,
go
let's
home.
leave 'em.
Let's go home. No, bro, you don't check it.
Why would you check the pulse rate? You know, I don't know if you're shooting.
Yes.
Security guard.
Whatever, but it's like crazy, there's only 3 people in the school that play it, so being 3 people in an outside orchestra is very cool, especially in like high school.
It's breaking news, bro.
No, Justin's one of the guys.
I will take either one.
It's looking like training topics, but maybe the I did look it up originally.
That's not true. Can we just do our work?
I also have to submit my, basically like take a test practices for, and then I have for, it's more time, like a little bit more theory, but like, I'm 17, right? I work this way, I asked the bartender,
Okay.
There's more than
Oh, well, the random, like, group generator just did not do this very well.
Oh, this is a random group generator?
Don't worry, I will intervene. All right, guys, so
We're lost, but it's okay.
can we look at this one? This is done on Desmos. So Jonathan, I apologize. I read the breaking point as 2, and it is not breaking at 2. So, looking on Desmos to verify my graph. And I wanted to show you guys this funny stuff, that if you want to say just this piece for your piecewise function, the curly bracket, you can type in exactly what you see. Like 1 over x minus 2, and then where it says comma x less than 4, I did curly bracket x less than 4. And then it graphed the red thing for me, just the red stuff. Okay? And then if I say the other half, which was x over 8, and then on this it said for x is greater than 4, if you say the curly bracket, x is greater than 4, it gives you that piece of the graph. So you can, and if you want to turn it on and off, you just tap the thing to say, I only want the red one, I only want the blue one. Spencer?
I don't understand because like when I'm looking at it, I put in the 4 into the x values and everything. And I got 1/2 for both of them. But-
Yep. Yep, okay.
But how is it, and so then I thought.
Okay.
But then I thought it was continuous, but that didn't.
Okay, well, and, yeah. Does it say equals in my definition? In what I'm saying in the problem, is there an equals 4? When it's actually 4, what's the value? Do you plug it into the top or the bottom, or did it not tell me anything?
I don't know.
It didn't tell me. There's no equal sign on any of those. So what is the value at h of 4?
You don't know.
I don't have one. It's undefined. Or you could say, does not exist. Which I've been just abbreviating as DNE, and I apologize, I use the acronyms a lot. I would just say, oh, DNE, LOL, BRB. You know, you guys speak in those 3-letter acronyms when BRB, you could just say be right back. It's just the same syllable, but no, BRB. Sorry, I have teenagers too. And, yeah.
I don't say.
You don't say BRB? They do. They do all the time.
Really?
All the time.
They say LOL.
No, well, say that, no, but they BRB a lot. Yeah. Okay. So the left and right hand limits, like Kevin told us how to do those in the beginning of class. So the left side of 4 and the right side of 4. So Dylan, on the right side or left side, which, the top branch, is that the left or the right?
If it's less than 4, it's left, right?
Okay, so, yeah, it's hard to say left, right? You mean left, correct? Yes.
I meant left, yeah.
Yes. So plugging into the top, what do we get?
LIM h of x over x into 4 negative equals 1/2.
Okay, you didn't say the name of the function, you might have had it written there, but it needs that. If you don't have the name of the function, that's like saying, hey, what's the square root? Square root, what? Naomi, on the other side, that's the bottom piece, what do I get? 1/2. And Spencer, is it defined at 4? Do I tell you anywhere, when x equals 4, plug it in here? Do I have that anywhere? No. So what is the value of h at 4 itself? Undefined. Okay. So what kind of discontinuity is it? Natalie, what kind of discontinuity is it gonna be that the height from each side is the same number, but it's not there as a function?
Removable.
Okay, yep. So Jonathan, you were right, and what was the coordinate where we would have to close things in if we wanted to glue it in? 4,1/2, like, that's where the little hole appears on the graph. And this is kind of getting at what we're going to in the next piece of this unit. Do you guys know how to do domain? Like find, when I ask what's the domain, it's what x values are allowed to go in. Am I allowed to put any single x value in this, or is something gonna cause like a square root of a negative or a divide by 0?
Can't put in a positive, you should not be allowed to put in positive or not.
I can make the numerator 0, but not the denominator. Can't put in -3, so the domain, I can't have -3. But the top of this factors, and that problem reduces, still not allowed to put in -3, but that's gonna create a removable discontinuity. Just a heads up. So your homework tonight is to finish through, top of page 9, depending on when is the bell ringing, in 10:15. Yep, very soon. Can you guys help and turn the desks into rows for me? At least help move stuff around a little.